Variables. Variables are like boxes where you can store data in your program. Think of them as labels for memory locations, where you keep values that you can use and change as your program runs. In C, before you use a variable, you need to declare it, which means telling the compiler what kind of data it will hold. For example, here, int, float, and char are data types specifying that age is an integer, height is a floating point number, and initial is a character. The equal to sign assigns values to these variables. Variables are fundamental because they allow your program to store information that can change over time, like user input or results from calculations. You can perform operations on variables, pass them to functions, and more. Data types. Data types define the type and size of data associated with variables. Using the correct data type ensures that your program uses memory efficiently and behaves as expected. Here are some basic data types in C, int, used for integers. Typically occupies 4 bytes of memory. Int, count equal to 10. Float, used for single precision floating point numbers, occupies 4 bytes. Float temperature equal to 36.6. Double, used for double precision floating point numbers, occupies 8 bytes. Double pi equal to 3.1415926535. Char, used for single characters, occupies 1 byte. Char grade equal to A. Choosing the right data type is crucial. For example, if you need to store a large number, long or double might be more appropriate than int or float. Printf function. The printf function is your go-to tool for displaying output on the screen. It's part of the standard input-output library, so make sure to include it at the top of your program. Printf uses format specifiers to format and insert variable values into your output string. Here's how you might use it. In this example, %t is a placeholder for an integer value, which is provided by the h variable. The n is an escape sequence that adds a new line after the output. Here are some common format specifiers. % or %t for integers, %f for floating point numbers, %l for double precision floating point numbers, % for characters. % for strings using printf effectively allows you to create dynamic and informative outputs, which is especially useful for debugging or interacting with users. Working with numbers. In C, you can perform arithmetic operations using operators like and %. Here's an example. Notice that when performing integer division, the result is also an integer, so any fractional part is discarded. If you want a more precise result, you should use floating point numbers. By casting A2, we ensure that the division operation is performed with floating point precision. Comments. Comments are notes in your code that the compiler ignores. They're incredibly useful for explaining what your code does, making it easier for you and others to understand it later. There are 2 types of comments in C. Single-line comments, start with and continue to the end of the line. 1. Multi-line comments, start with and end with. They can span multiple lines. 2. Using comments effectively is a good programming practice. They help document your code's purpose, explain complex logic, and make maintenance easier. Constants. Constants are variables whose value cannot change once set. They are useful for defining values that should remain the same throughout the program, like mathematical constants or configuration values. There are 2 ways to define constants in C. Using const keyword, here, pi is a floating point constant. Using hashtag define preprocessor directive. With hashtag define, you're creating a macro that the preprocessor replaces before compilation. Constants improve code readability and maintainability because you can change the value in one place if needed, and it will update throughout your code. Getting user input. To make your programs interactive, you'll often need to get input from the user. In C, you use the scanf function for this purpose, which reads formatted input from the standard input. Here's an example. In scanf, the D format specifier tells the function to expect an integer input. The andage is the address of operator, which provides the memory address where the input value should be stored. Be cautious with scanf, as improper use can lead to unexpected behavior or security vulnerabilities. Always ensure that the format specifiers match the variable's data types. Building a basic calculator. Let's put together what we've learned to build a simple calculator that adds 2 numbers. In this program, we declare 3 float variables, num and sum. We prompt the user to enter 2 numbers and read them using scanf. We calculate the sum of the 2 numbers. We display the result using printf, formatting the output to show 2 decimal places, with %. This basic calculator can be expanded to include other operations like subtraction, multiplication, and division, building a Mad Libs game. Mad Libs is a fun game where you create a story by filling in blanks with words. Let's create a simple version in C. In this program, we declare character arrays to hold the user's inputs. We use scanf to read the inputs. Notice the different format specifier for celebrity too. Read a full line, including spaces. We print out a simple poem using the user's words. This illustrates how you can use variables and user input to create interactive programs. Arrays. Arrays are collections of variables of the same data type, stored in contiguous memory locations. They allow you to store multiple values under a single variable name, accessed by an index. Here's how you declare and use an array. Arrays are zero-indexed, meaning the first element is at index 0. They are useful when you need to store and manipulate lists of data, such as scores, names, or any collection of items. Functions. Functions are blocks of code that perform specific tasks and can be reused throughout your program. They help make your code modular and organized. Here's how you define and use a function. In this example, we define a function greet that takes no parameters and returns nothing. In main, we call greet, which executes the code inside the function. Functions can also take parameters and return values. Functions make your code more manageable and reusable, especially as your programs grow in size and complexity. Return statement. The return statement exits a function and optionally sends a value back to the calling code. It's essential in functions that perform calculations or need to provide results. Here's an example with a function that calculates the factorial of a number. In this recursive function, if n is less than or equal to 1, the function returns 1. Otherwise, it returns n multiplied by the factorial of n1. The return statement provides the result back to where the function was called. Understanding how return works is crucial for writing functions that produce and use data effectively. If statements. If statements allow your program to make decisions based on conditions. They control the flow of your program by executing code blocks only when certain conditions are met. Here's a simple example. In this program, the if statement checks if score is greater than or equal to 90. If not, it moves to the else, if statements. The first condition that evaluates to true executes its code block. If none of the conditions are met, the else block executes. If statements are essential for adding logic to your programs, allowing them to react differently under different circumstances, building a better calculator. Let's enhance our basic calculator to perform multiple operations based on user input. In this program, we use scanf to get the operator and operands from the user. A switch statement handles different operations based on the operator. We perform the calculation and display the result. This calculator can add, subtract, multiply, and divide two numbers, making it much more versatile. Switch statements. Switch statements are a clean way to perform different actions based on the value of a variable, especially when dealing with multiple possible values. Here's an example. In this code, the switch statement checks the value of day. Each case represents a possible value. The break statement exits the switch after a case is executed. The default case executes if none of the other cases match. Switch statements are ideal when you have a variable that can take on discrete values and you want to execute different code for each value. Structs. Structures allow you to create custom data types that group related variables. They are like templates for objects, letting you model complex data. Here's how you define and use a struct. In this example, we define a struct named person with name, age, and height as members. We create an instance of person called person. We use strcpy to assign a string to person. We access members using the dot operator. Structures are powerful for organizing data, especially when dealing with records or objects that have multiple attributes. While loops allow you to execute a block of code repeatedly as long as a condition is true. They're useful when you don't know in advance how many times you'll need to loop. In this code, the loop will continue as long as count is less than or equal to 5. Inside the loop, we print the current value of count and then increment it. Once count exceeds 5, the loop exits. While loops are great for situations where the loop's continuation depends on dynamic conditions, building a guessing game. Let's create a simple number guessing game. In this game, we generate a random number between 1 and 100. The user tries to guess the number. We give hints if the guess is too high or too low. The game continues until the user guesses correctly. This example combines loops, conditionals, and user input to create an interactive experience. For loops are another way to execute code repeatedly, especially when you know how many times you want to loop. In this loop, int I equal to 1 initializes the loop variable I less than equal to 5 is the loop condition. I increments I after each iteration. The loop runs 5 times, printing the iteration number each time. For loops are concise and ideal for iterating over arrays or running a block of code a specific number of times. 2D arrays and nested loops. 2D arrays are arrays of arrays, useful for representing matrices or grids. Nested loops often work with 2D arrays. Here's how you might declare and use a 2D array. In this code, we use nested for loops to initialize and display the matrix. The outer loop iterates over the rows, and the inner loop iterates over the columns. This pattern is common when working with multidimensional data structures. Understanding 2D arrays and nested loops is essential for tasks like image processing, game development, or any application involving grids. Memory addresses. Every variable in C has a memory address, which you can access using the address of operator, and understanding memory addresses is crucial for working with pointers. Here's an example. In this program, we declare an integer num and assign it a value. We use p in printf to display the memory address of num. The AND operator gets the address of num. Knowing about memory addresses helps you understand how data is stored and manipulated in your programs. Pointers. Pointers are variables that store memory addresses. They point to the location of other variables. Pointers are powerful but require careful handling. Here's how you declare and use pointers. In this code, int ptr declares a pointer to an integer. ptr equal to ANDNum assigns the address of num to ptr. ptr dereferences the pointer to access the value at that memory address. Pointers are essential for dynamic memory allocation, passing variables by reference to functions, and working with data structures like linked lists. Dereferencing pointers. Dereferencing a pointer means accessing or modifying the value located at the memory address the pointer refers to. Here's an example. In this program, we pass the address of num to the increment function. Inside the function, we dereference the pointer value and increment the value it points to. This changes the original num variable in main. Dereferencing is a core concept in pointer manipulation and allows functions to modify variables outside their local scope. Writing files. Writing to files allows your program to save data for later use. Here's how you can write to a file in C. #include less than stdio.h greater than int main. File fptr equal to fopen, open file for writing. If printf, return 1, for printf. For close the file printf return 0. In this code, we declare a file pointer fptr. Fopen opens the file output.txt in write mode. We check if the file was opened successfully. Printf writes formatted data to the file. We close the file using fos. File operations are essential for programs that need to persist data, like logs, configurations, or user data. Reading files. Reading from files allows your program to load and process data stored in files. Here's how you can read from a file. In this program, #include less than stdio.h greater than int main. File fptr, char line, fptr equal to fopen, open file for reading. If printf return 1, while fptr. Printf, close the file return 0. We open output.txt in read mode. We use feggeast to read each line from the file. The loop continues until all lines are read. We print each line to the console. Understanding file 1.0 is crucial for applications that need to process external data, such as configuration files, data analysis programs, or any application that interacts with files.